The concept of establishing a human presence on the moon has transitioned from the realm of science fiction to a tangible goal, driven by advancements in technology and international collaboration. The creation of a lunar base presents a unique set of challenges and opportunities, necessitating innovative solutions across various domains. Technological innovations such as in situ resource utilization and 3D printing are pivotal in constructing habitats using local materials like lunar regolith, significantly reducing the logistical burden of transporting materials from Earth. Energy systems, including vertically deployable solar arrays and the potential use of lunar regolith for power generation, are being developed to ensure a reliable power supply in the moon's harsh environment. The logistical challenges of establishing a moon base are formidable, encompassing transportation systems, communication networks, and supply chain management. The Artemis program, in collaboration with commercial partners like SpaceX, is at the forefront of developing the necessary transportation infrastructure to support lunar missions. Additionally, the establishment of lunar spaceports and robust communication networks are critical for the efficient operation and safety of lunar activities. Economically, the feasibility of a lunar base is underpinned by a comprehensive cost analysis and the potential for significant revenue from lunar activities. The market for lunar goods and services is projected to grow substantially, driven by transportation and ISRU markets. International collaboration, as outlined in agreements like the Artemis Accords, is essential for distributing financial burdens and leveraging global expertise. This research report delves into the multifaceted aspects of creating a moon base, exploring the technological, logistical, and economic dimensions that are shaping the future of lunar exploration. The development of a lunar base necessitates innovative construction techniques that can withstand the moon's harsh environment. One of the most promising approaches is the use of in situ resource utilization, which involves using local materials, such as lunar regolith, to construct habitats and infrastructure. This method significantly reduces the need to transport materials from Earth, thereby lowering costs and logistical challenges. ICON, a leader in advanced construction technologies, is working on the Olympus system, which aims to utilize lunar and Martian resources for building structures. 3D printing is another critical technology being explored for lunar construction. This technique allows for the creation of complex structures using minimal resources and can be adapted to use lunar regolith as a building material. The Haley hybrid concept proposes using established technologies to erect thermal and micrometeoritic shelters over pressurized habitats, providing early operational capability for lunar missions. Reliable energy systems are crucial for sustaining a lunar base. NASA is collaborating with commercial companies to develop vertically deployable solar array systems that can autonomously deploy and retract on the lunar surface. These systems are designed to withstand the moon's abrasive dust and steep terrain, providing a stable power source for habitats and other infrastructure. In addition to solar power, research is being conducted on using lunar regolith for energy generation. The regolith contains metallic dust with oxygen, which can be used in thermite reactions to produce energy. This approach not only provides a sustainable power source, but also supports the extraction of useful materials from the regolith, facilitating further lunar development. Creating a habitable environment on the moon requires advanced life support systems that can protect inhabitants from extreme temperatures, radiation, and lunar dust. The Artemis program is focusing on developing these systems, which include robust habitats that can support long-term human presence. These habitats must be equipped with life support solutions to ensure astronaut safety during extended stays. The use of autonomous robots for site preparation and habitat assembly is also being explored. These robots can operate in the harsh lunar environment, reducing the need for human intervention and allowing for quicker and more efficient construction of lunar settlements. Efficient transportation systems are essential for the success of a lunar base. The Artemis program aims to establish a sustainable presence on the moon, which includes developing Earth-Moon transportation systems for cargo and crew. Partnerships with commercial entities like SpaceX are crucial in achieving this goal, as they provide the necessary technology and expertise for lunar missions. The use of the Lunar Gateway, a command and control module in lunar orbit, will facilitate surface expeditions and serve as a platform for new science and technology demonstrations. This infrastructure will support the transportation of astronauts and equipment, enhancing the overall logistics of lunar exploration. The extraction and utilization of lunar resources are vital for the sustainability of a moon base. The moon's south pole is of particular interest due to its potential water ice deposits, which can be used for life support and fuel production. The Artemis program and international collaborations are focused on exploring these resources and developing technologies for their extraction. In situ resource utilization technologies are being developed to enable the production of fuel, water, and oxygen from local materials. These technologies will reduce the dependency on Earth supplies and support long-term lunar operations. Rovers equipped with ISRO experiments will play a crucial role in assessing the availability and extraction of these resources. In summary, the creation of a moon base involves a range of technological innovations, from advanced construction techniques and energy systems to life support and resource utilization. These technologies are being developed through international collaborations and partnerships with commercial entities, paving the way for a sustainable human presence on the moon. Developing effective transportation systems is a critical logistical challenge in establishing a moon base. The transportation infrastructure must support the movement of resources, equipment, and personnel between Earth and the moon. This requires advancements in propulsion technologies, reusable launch vehicles, and in-space transportation systems. Current efforts focus on developing spacecraft capable of carrying heavy payloads and ensuring safe landings on the lunar surface. For instance, NASA's Artemis program aims to utilize the Space Launch System and the Orion spacecraft to transport astronauts and cargo to the moon. Additionally, private companies like SpaceX are developing the Starship, a fully reusable spacecraft designed for lunar missions. The establishment of lunar spaceports is essential for the efficient operation of transportation systems. These spaceports will serve as hubs for landing, refueling, and launching spacecraft. The design and construction of lunar spaceports must consider the moon's unique environment, including its low gravity and lack of atmosphere. Innovations in construction techniques, such as using in situ resources like lunar regolith, are being explored to build durable and sustainable infrastructure. The development of spaceports will also require international collaboration to establish standardized protocols and regulations for lunar operations. Reliable communication networks are vital for the operation and safety of a moon base. These networks must support data transmission between the moon and Earth, as well as within the lunar base itself. The moon's distance from Earth poses challenges for real-time communication, necessitating the development of advanced communication technologies. NASA's Lunar Gateway, a planned space station orbiting the moon, aims to facilitate communication and provide a platform for scientific research. Additionally, satellite constellations around the moon are being considered to enhance communication capabilities and ensure continuous connectivity. To ensure the reliability of communication networks, redundancy is crucial. Multiple communication pathways and backup systems must be established to prevent disruptions. This includes the deployment of relay satellites and the use of different frequency bands to mitigate interference. The integration of artificial intelligence and machine learning can also enhance the resilience of communication networks by enabling autonomous monitoring and fault detection. The lunar supply chain is a complex logistical challenge that requires sophisticated planning and coordination. Managing suppliers, manufacturers, and third-party logistics involves developing robust management systems and risk mitigation strategies. The supply chain must be resilient to disruptions, such as launch failures or orbital miscalculations, which could jeopardize the delivery of essential resources to the moon base. To reduce dependency on Earth-based supplies, in situ resource utilization is a key strategy. ISRU involves extracting and processing lunar resources, such as water ice and regolith, to produce essential materials like oxygen, water, and construction materials. This approach not only minimizes the need for resupply missions, but also supports the sustainability of the moon base. NASA's Artemis program includes plans to demonstrate ISRU technologies on the lunar surface. Building the necessary infrastructure to support a moon base is a significant logistical challenge. This includes the construction of habitats, power generation systems, and life support systems. The harsh lunar environment, characterized by extreme temperature fluctuations and micrometeorite impacts, necessitates the use of durable materials and innovative construction techniques. Prefabricated modules and 3D printing using lunar regolith are being explored as potential solutions. Power generation and storage are critical components of lunar infrastructure. The moon's 2-week cycles of daylight and darkness require reliable energy solutions. Solar power, supplemented by nuclear generators, is a primary option for providing continuous energy. Energy storage systems, such as advanced batteries and fuel cells, are essential for maintaining power during the lunar night. Research is ongoing to develop efficient and sustainable power systems for lunar applications. The establishment of a moon base is a global endeavor that requires international collaboration and regulatory frameworks. Multiple nations and private entities are involved in lunar exploration, necessitating the development of agreements and protocols to govern activities on the moon. The Artemis Accords, for example, outline principles for peaceful lunar exploration and resource utilization. These agreements aim to foster cooperation, prevent conflicts, and ensure the responsible use of lunar resources. Legal and ethical considerations are integral to the regulation of lunar activities. Issues such as property rights, resource ownership, and environmental protection must be addressed to ensure equitable and sustainable development. The Outer Space Treaty of 1967 provides a foundational framework, but further legal instruments are needed to address the complexities of modern lunar exploration. International dialogue and cooperation are essential to establish comprehensive legal and ethical guidelines for lunar operations. The development of a lunar base is a significant financial undertaking, with estimates suggesting a total cost of approximately $35 billion. This figure includes the construction of habitation and support modules, which alone are projected to cost around $17 billion. The development of the Altair lander, necessary for transporting cargo to the lunar surface, is estimated at $12 billion, while a universal lander module adds another $2 billion to the budget. These costs are exclusive of the heavy-lift Ares EV, or equivalent launch systems, which are essential for transporting the lunar base components from Earth to the Moon. Operating a lunar base is projected to cost approximately $7.35 billion annually, assuming continuous occupancy. This includes the costs of 2 Ares launches with Altair landers, estimated at $2 billion per year, and 2 Orion launches costing $0.6 billion annually. Additionally, 15 medium launches with a universal cargo lander are expected to cost $3.75 billion per year. These figures highlight the logistical challenges of maintaining a lunar base, particularly the need for frequent resupply missions from Earth, which significantly contribute to the overall operating costs. The potential revenue from lunar activities is substantial, with the market for lunar goods and services expected to grow to a cumulative $170 billion by 2040. The primary revenue drivers are anticipated to be lunar transportation, projected to be worth approximately $100 billion, and the in situ resource utilization market, expected to reach about $63 billion. The ISRU market, in particular, is driven by the demand for propellant, which could significantly reduce the costs of lunar operations by utilizing resources found on the Moon. The establishment of a lunar base requires significant technological advancements and infrastructure development. Key areas of focus include wireless power beaming infrastructure, surface-to-surface and surface-to-lunar orbit communications, and mobility solutions for equipment on the lunar surface. These technologies are crucial for sustaining economic activity on the Moon, particularly in energy-deficient areas like the lunar South Pole. The development of these technologies is expected to be a collaborative effort involving both government agencies and commercial entities. International collaboration is expected to play a crucial role in the development of a lunar base. The Beijing Declaration has identified the lunar base as an ideal project for international cooperation in space exploration. This collaboration could help distribute the financial burden and leverage the expertise of multiple countries. Additionally, the market dynamics are expected to shift over time, with commercial actors playing an increasingly significant role in lunar activities. While the market is currently institution-driven, the involvement of non-space actors is anticipated to grow, driven by the potential for technology spin-offs and increased investment in space missions. The economic viability of a lunar base hinges on several factors, including the successful demonstration of key technologies, the establishment of a sustainable supply chain, and the development of a robust market for lunar resources and services. The potential for significant cost reductions through ISRO and the increasing interest from commercial entities suggest a promising future for lunar economic activities. However, the realization of these prospects will require substantial investment, international collaboration, and continued technological innovation. As the market for lunar activities expands, the economic feasibility of a lunar base is likely to improve, paving the way for a sustainable human presence on the Moon. The establishment of a moon base represents a monumental step in human space exploration, offering unprecedented opportunities for scientific discovery and economic development. The technological innovations required for this endeavor, such as advanced construction techniques and energy systems, are being actively developed through collaborations between governmental agencies and commercial entities. These innovations are crucial for overcoming the Moon's harsh environment and ensuring the sustainability of a lunar base. Logistical challenges, including transportation, communication, and supply chain management, are being addressed through strategic partnerships and the development of new infrastructure. The Artemis program and initiatives like the Lunar Gateway are pivotal in establishing a sustainable presence on the Moon, facilitating both scientific research and commercial activities. Economically, the potential for a thriving lunar market is significant, with projections indicating substantial growth in lunar transportation and resource utilization sectors. The successful implementation of in situ resource utilization technologies could drastically reduce costs and enhance the economic viability of lunar operations. International collaboration remains a cornerstone of this endeavor, fostering cooperation and ensuring the responsible use of lunar resources. In conclusion, the creation of a moon base is a complex yet achievable goal that requires continued innovation, collaboration, and investment. As technological advancements progress and international partnerships strengthen, the vision of a sustainable human presence on the Moon is becoming increasingly attainable, paving the way for future exploration and utilization of extraterrestrial resources.